The National Electrical Code, specifically Section 110.26 current, addresses working space in front of electrical equipment. This section mandates that working space in front of equipment or live parts, which may require examination, adjustment, servicing, maintenance, or repair while energized, shall be not less than 3 feet. This requirement is crucial for ensuring the safety of personnel who may need to work on electrical equipment while it is still powered. Now, let's consider 404.8, which deals with the accessibility of bus plugs. This section states that bus plugs shall be accessible from at least one side and shall be provided with a means to prevent accidental contact with live parts. The code emphasizes accessibility to ensure that workers can safely interact with bus plugs for various purposes, such as inspection or maintenance. Based on these code references, we can draw several important conclusions. Firstly, the 3-foot working clearance required by 110.26 current applies to the space in front of bus plugs, even when they are installed in an open ceiling. This is because bus plugs may require examination, adjustment, servicing, maintenance, or repair while energized. The need for this clearance is not diminished by the height of the ceiling or the specific installation environment. Secondly, the means of access to bus plugs may be by hot sticks or other suitable means, as per 404.8. However, the 3-foot working clearance is still required in front of the bus plugs themselves. This means that even if hot sticks are used to operate or maintain the bus plugs, the physical space in front of the equipment must still be clear to allow for safe movement and operation. Now, let's address the situation where a duct is installed in the 3-foot working clearance space in front of the bus plugs. According to the NEC, this would be a violation of 110.26 colon. The presence of a duct within this required clearance zone obstructs the necessary space for safe working conditions and hinders the ability to perform maintenance or repairs on the bus plugs. In such a situation, it is recommended to relocate the duct or provide an alternative means of access to the bus plugs that complies with the code. This could involve rerouting the ductwork or creating a clear path to the bus plugs that meets the 3-foot clearance requirement. It's important to consider additional factors to ensure safety and compliance. The NEC does not specify a maximum height for working clearance. However, it is generally recommended to provide at least 6 feet of headroom above electrical equipment. This headroom allows workers to stand comfortably and move freely while performing tasks around the equipment. While the height of the ceiling, such as 20 feet in this case, does not affect the requirement for a 3-foot working clearance in front of bus plugs, it's still important to ensure adequate headroom for personnel working in the area. When determining the appropriate working clearance, the safety of personnel working on or around electrical equipment should be the primary consideration. The goal is to create a safe working environment that minimizes the risk of accidents and injuries. By adhering to the NEC guidelines and taking into account additional safety factors, you can ensure that electrical equipment is installed and maintained in a manner that protects workers and promotes efficient operation. Now to go more in depth about Section 110.26 current, the purpose of this is to ensure that personnel have adequate space to safely work on electrical equipment while it is energized. The minimum 3-foot clearance is measured from the enclosure containing live parts to any grounded object or other equipment. This clearance is essential for preventing accidental contact with live parts and allowing workers to perform tasks without unnecessary obstructions. There are specific exceptions to the 3-foot clearance requirement, depending on the voltage of the equipment and the conditions of the surrounding environment. For example, if the voltage to ground is 150 volts or less and there are no exposed live parts in the opposite side of the working space, the required clearance may be reduced to 2.5 feet. However, it's important to carefully evaluate the specific circumstances and consult the NEC to determine the appropriate clearance for each situation. In addition to the horizontal clearance, it's also important to consider the vertical clearance above electrical equipment. As mentioned earlier, it is generally recommended to provide at least 6 feet of headroom above electrical equipment to allow workers to stand comfortably and move freely. However, the NEC does not specify a minimum headroom requirement, so it's important to use good judgment and consider the specific needs of the work environment. When assessing working clearance, it's important to consider all potential obstructions that could impede access to the equipment. This includes ducts, pipes, walls, and other equipment. If any of these obstructions encroach on the required working space, they must be relocated or modified to ensure compliance with the NEC. In some cases, it may be possible to use barriers or guards to protect workers from accidental contact with live parts. However, these barriers must be carefully designed and installed to ensure that they do not impede access to the equipment or create other hazards. Furthermore, 404.8 stipulates that bus plugs must be accessible. Accessibility refers to the ability to reach the bus plugs easily and safely for inspection, maintenance, or repair. This means that the bus plugs must be located in a place where workers can access them without having to climb over obstacles or navigate through cramped spaces. If bus plugs are located in a hard-to-reach area, it may be necessary to provide a platform or other means of access to ensure compliance with the NEC. Additionally, 404.8 requires that bus plugs be provided with a means to prevent accidental contact with live parts. This can be accomplished through the use of covers, barriers, or other protective devices. The purpose of these devices is to prevent workers from accidentally touching live parts while working on or around the bus plugs. It is important to ensure that these protective devices are properly installed and maintained to ensure their effectiveness. When considering the installation of bus plugs, it is also important to take into account the environmental conditions of the location. If the bus plugs are located in a damp or wet environment, it may be necessary to use special enclosures or other protective measures to prevent corrosion or electrical shock. Similarly, if the bus plugs are located in a hazardous location, such as an area with explosive gases or dust, it may be necessary to use explosion-proof enclosures or other specialized equipment. The NEC provides specific requirements for the installation of electrical equipment in hazardous locations, and it is important to comply with these requirements to ensure the safety of workers and the prevention of fires or explosions. In addition to the NEC, there may be other applicable codes or standards that must be followed when installing bus plugs. These may include local building codes, fire codes, or industry standards. It is important to consult with local authorities and qualified professionals to ensure that all applicable codes and standards are met. Finally, it is important to remember that the safety of personnel should always be the primary consideration when working on or around electrical equipment. This means following all applicable safety procedures, using appropriate personal protective equipment, and taking steps to prevent accidents. If you are not qualified to work on electrical equipment, it is important to seek the assistance of a qualified electrician. By following these guidelines, you can ensure that bus plugs are installed and maintained in a safe and compliant manner. Let's delve a little deeper into specific scenarios. Imagine a bus plug installed 18 feet above the floor in a manufacturing facility. While the ceiling is 20 feet high, a large ventilation duct runs horizontally about 2.5 feet directly in front of the bus plug. Even though hot sticks might be used to operate the disconnect, the 2.5-foot clearance violates 110.26 cone. Someone needing to examine the bus plug, perhaps to troubleshoot a voltage issue, lacks sufficient working space. Relocating the ductwork is the ideal solution. However, if that's impossible, a physical barrier providing a full 3 feet of clear space from the energized components to the duct could be considered, although this option should be carefully evaluated by a qualified electrical engineer. Now consider a situation where the bus plug is accessible via a rolling platform. The platform allows an electrician to safely reach the bus plug. However, if the platform, when positioned for access, only provides a 2-foot clearance to a nearby wall, that still violates 110.26 cone. The working space requirement is independent of the access method. The electrician needs that 3-foot space to safely maneuver and work, regardless of how they reach the equipment. What about a bus plug that feeds a critical piece of machinery? Downtime is extremely costly. Regular infrared scanning is performed to detect hot spots, a sign of potential failure. Even though the infrared scan can be done from several feet away, the NEC still applies. The act of performing the scan is considered examination and potentially servicing. If the clearance is obstructed, even temporarily, it's a violation. The point here is not to circumvent the rules, but to understand why they exist. The working space isn't just about physically touching the equipment. It's about having room to diagnose, assess, and potentially repair energized components safely. It acknowledges that even with hot sticks and remote tools, human intervention might be needed. Now let's address a common misconception. Some might argue that if the bus plug is rarely, if ever, accessed while energized, the 3-foot rule is less critical. This is incorrect. The code states which may require examination, adjustment, servicing, maintenance, or repair while energized. The possibility, not the certainty, triggers the requirement. Predicting the future is impossible. An unforeseen issue could arise that necessitates live work. Having that clear space from the outset is a proactive safety measure. Thinking about headroom, while the NEC doesn't mandate a specific amount, consider the scenario. An electrician is 6 feet tall. The bus plug is mounted 7 feet above the floor. While there's theoretically 1 foot of headroom, realistically, the electrician will be crouching or bending over, significantly reducing their maneuverability and increasing the risk of accidental contact. Aiming for at least 6 feet of headroom above the equipment, not necessarily the floor, is good practice. Another point to consider is the type of equipment opposite the working space. 110.26a outlines different clearance requirements based on whether the opposite side is grounded, insulated, or has exposed live parts. The most stringent requirement, 4 feet of clearance, applies when there are exposed live parts on both sides of the working space. Bus plugs, by their nature, often have exposed live parts, making this a common scenario. Always verify the specific conditions to ensure the correct clearance is maintained. And let's not forget about proper lighting. 110.26d requires sufficient illumination for safe work. A dimly lit area increases the risk of errors and accidents. Adequate lighting should be provided to clearly see the equipment and surrounding area. This is particularly important for bus plugs located in high ceilings or confined spaces. Thinking practically, before installing a bus plug, a thorough site survey is crucial. Identify potential obstructions, assess the available working space, and plan accordingly. It's far easier to address these issues during the design phase than after the installation is complete. Involve a qualified electrical engineer in the planning process. They can help ensure compliance with all applicable codes and standards. Regular inspections are also essential. Check for new obstructions, damaged equipment, and any other potential hazards. Address any issues promptly to maintain a safe working environment. Remember, electrical safety is not a one-time effort. It's an ongoing commitment. By understanding and adhering to the NEC requirements for working space around bus plugs, you can significantly reduce the risk of accidents and injuries. The 3-foot clearance is not just an arbitrary number. It's a carefully considered safety measure designed to protect those who work on or around energized electrical equipment. Finally, never compromise on safety. If you're unsure about any aspect of the installation or maintenance of bus plugs, consult with a qualified electrical professional. Your safety and the safety of others depend on it. Understanding the nuances of the National Electrical Code is paramount for electrical safety. Proper working clearances are not merely suggestions, they are critical safeguards designed to protect personnel. Neglecting these requirements can lead to severe consequences, including electrical shock, arc flash incidents, and even fatalities. It's crucial to view these regulations not as obstacles but as essential components of a comprehensive safety strategy. Consider, for instance, the potential ramifications of disregarding the 3-foot working clearance around bus plugs. An electrician tasked with troubleshooting a fault might find themselves working in a cramped space, struggling to maneuver tools and equipment. This limited space increases the likelihood of accidental contact with energized components, placing the electrician at grave risk. Furthermore, restricted movement can impede the ability to react quickly in the event of an arc flash or other electrical incident. In such scenarios, even a fraction of a second can make the difference between life and death. The NEC emphasis on accessibility is equally vital. Bus plugs must be readily reachable for inspection, maintenance, and repair. Obstructed access can delay critical maintenance tasks, potentially leading to equipment failures and costly downtime. Moreover, forcing electricians to navigate hazardous obstacles to reach equipment increases the risk of accidents. Implementing measures to prevent accidental contact with live parts is another fundamental aspect of electrical safety. Covers, barriers, and other protective devices serve as vital safeguards, minimizing the risk of unintentional contact with energized components. Regular inspections of these protective measures are essential to ensure their continued effectiveness. Damaged or missing covers should be promptly replaced to maintain a safe working environment. Environmental factors also play a significant role in electrical safety. Damp or wet conditions can significantly increase the risk of electrical shock. When installing bus plugs in such environments, it's imperative to utilize appropriate enclosures and protective measures to prevent moisture from compromising the electrical system. Similarly, in hazardous locations where explosive gases or dust may be present, specialized equipment designed to mitigate the risk of ignition is crucial. The NEC provides detailed guidelines for electrical installations in hazardous locations, and strict adherence to these guidelines is essential. Beyond the NEC, various other codes and standards may apply to electrical installations. Local building codes, fire codes, and industry standards all contribute to a comprehensive framework for electrical safety. Consulting with local authorities and qualified professionals is essential to ensure compliance with all applicable regulations. The ultimate goal of all these regulations and guidelines is to protect personnel from electrical hazards. Prioritizing safety in all aspects of electrical work is paramount. This includes providing adequate training, utilizing appropriate personal protective equipment, and implementing robust safety procedures. Continuous vigilance and a commitment to safety are essential for creating a work environment where electrical accidents are minimized. Never underestimate the importance of seeking expert advice when dealing with electrical systems. Qualified electricians and electrical engineers possess the knowledge and experience to ensure that electrical installations are safe, compliant, and reliable. Their expertise can be invaluable in identifying potential hazards and implementing effective solutions. In conclusion, strict adherence to the NEC and other relevant codes and standards is essential for ensuring electrical safety. Proper working clearances, accessibility, protective measures, and environmental considerations all contribute to a safe working environment. By prioritizing safety in all aspects of electrical work and seeking expert advice when needed, we can minimize the risk of electrical accidents and protect personnel from harm. Remember, electrical safety is not a matter of luck, it's a matter of knowledge, preparation, and unwavering commitment.